infinite series. An expression of the form u1 plus u2 plus u3 up to un or up to infinity is called infinite series. In symbolic form, summation n1 to infinity un, this is the expression. In sequence of partial sum u1, u2, u3 up to un denoted by Sn, limit n tending to 1 to n un. This is the sum of n terms. Sum of n terms. Convergence of an infinite series. An infinite series un is said to be convergent if n tending to infinity Sn is equal to finite number. Summation un is said to be divergent if n tending to infinity Sn is equal to plus infinity or minus infinity. This is the convergence test of the series. Summation un is oscillate if Sn does not have a unique limit. Some remarks: a series summation un is convergent then limit n tending to infinity un is equal to 0. That means n terms applying limit n tending to infinity gives 0. The converse of above result is not true. That means if limit n tending to infinity un equal to 0, then the series need not to be convergent. For example, this term as n tending to infinity 1 upon n is equal to 0, but this series is divergent series. Now some prove that geometric series 1 plus x square plus x cube up to infinity is convergent in this condition, divergent in this, oscillate finitely, oscillate infinitely. Now we see this is the geometric progression, and the sum of geometric progression of n terms is a 1 minus r to the power n divided by 1 minus r. R is the common ratio, that is x. We get by the sum formula is this expression. Here we consider common ratio is less than 1. Common ratio less than 1. Then we get this form by simplifying, and as n tending to infinity we get only this term, because this becomes 0 as n tending to infinity. X to the power n tending to infinity, x to the power n is equal to 0 as mod of x is less than 1. Okay, Sn is the convergent, hence the given series convergence, because Sn n tending to infinity give finite value. Now for x is greater than or equal to 1, if x is 1 or greater than 1, then this sum become 1 plus up to infinity, then series divergent. If x is greater than 1, then thus by the help of some formula we get this expression, and as n tending to infinity, x to the power infinity is 0. X to the power n tending to infinity is not 0, that is infinity. X, this becomes 0 if mod of x is lesser than 1, but here x is greater than 1, that's why this become infinity and we get infinity. So given series is divergent. Now for x is equal to minus 1, we get oscillatory sequence. As n tending to infinity, Sn become 1 or 0 as n is odd or even. Now for x is less than minus 1, that means minus x is less than 1, and the by the help of some formula we get this form, consider minus x is equal to p, then we get this expression, and as n tending to infinity we get minus infinity or plus infinity. So this series oscillate infinitely, hence given series is oscillate infinitely. Alternative series test or Leibniz test. In the Leibniz test, n tending to infinity, un is equal to 0 and un plus 1 is less than un. That means any term is less than its preceding term. Here we see alternate minus and plus and summation minus 1 to the power n minus 1 un. This is the general term and un is 1 by n. As n tending to infinity, this un is equal to 0. So this condition hold and every term is less than its preceding term. Similarly, we can see un plus 1 minus un, that gives a value less than 0. That means every term is less than its preceding term. Now we discuss about this series. The general term is 1 divided by n plus 1 under root n plus 1. This is also apply here Leibniz test because every term is less than its preceding term, and as n tending to infinity we get here 0. So Leibniz test satisfy and fulfill.